How do you minimize network disruptions? In today's world, disruptions have big consequences. Operational downtime, financial loss, and safety risks are real. You need a proven, reliable solution. I'm an avatar of Christopher Roy, Portfolio Manager at Siemens for Scalance Devices. Let's explore network redundancy mechanisms to minimize downtime. Discover what's new and rethink possibilities. In operational technology, availability is key. A Siemens study in 2022 showed the financial impact of downtime. Shocking results emerged. In the automotive industry, 1 hour of downtime can cost 2 million euros. In oil and gas, up to 1.5 million euros. Manufacturing can reach tens to hundreds of thousands of euros. With so much at stake, and with such high consequences, it's clear you need a solution that you can use to minimize the impact of network disruptions. And for that we have network redundancy mechanisms. Let's explore network redundancy mechanisms with a mountain climber analogy. Imagine a network with two devices communicating by sending data packets. Picture this packet as a climber starting at the mountain's base, aiming for the summit. Now let's examine our first redundancy mechanism. Imagine the climber can clone himself and the mountain. If one path is blocked, the clone takes another path and reaches the top. If we translate this into the OT world, here we have a simple network setup for PRP, where we've got an industrial data center that needs to communicate to a switch further down in the network. The way it's connected with PRP is through two distinct local area networks. Local area network A and B. The industrial data center duplicates data and sends copies through local networks to the switch. If there's a disruption in one network, no problem. A duplicate is already on the way in another network. What's that mean? It means zero network downtime, known as bumpless technology. Let's see another redundancy mechanism. Next, we'll look at HSR. That's high availability, seamless redundancy. Think of it as cloning the climber, like PRP. This time, we won't clone the mountain. Both the climber and the clone will ascend together, taking different paths. If there's an obstruction, the clone is already on its way up. In the OT world, devices are connected in a ring for HSR. Like climbers, a switch communicates with another switch in this ring. They'll clone their data packet and send copies down both ends of the ring to the switch. The switch accepts the first packet and dismisses the duplicate. If there's a network issue on one side, another packet is already en route on the other path. This ensures zero downtime, another example of bumpless technology. Let's look at our final redundancy mechanism, MRP, or Media Redundancy Protocol. Think of it as cloning the effort. Our climber will do a bit of homework up front and plan a second route to the top. He'll take his preferred path to the summit, but if there's an issue, he'll backtrack and use the alternative path. Back to the OT world, similar to HSR, MRP uses connected devices in a ring. If a switch wants to communicate with another switch in the ring, it sends the data packet once along the preferred path. If there's a fault, the switch resends the packet along the alternative path to reach the destination. Unlike HSR and PRP, the sending switch briefly identifies issues before resending data along an alternate path. This causes a tiny network disruption, lasting only 200 milliseconds, about the time of a blink. It's a very quick disruption. These concepts aren't new. They've been standardized in IEC 62439-2 for over 10 years. So, when defining your path to availability, we have a Scalance X solution for implementing PRP in your network. Then you can look at our entire portfolio. All of them are operable within a PRP network. For MRP, use our managed switches and routers with specialized firmware. For a PRP or HSR solution, use our advanced switches and routers. Each product family offers a wide selection, varying in port densities, data rates, and more to meet your network needs. Let's discuss new innovations from Scalance, HSR, PRP, and MRP redundancy mechanisms. Let's look at the high-level network topology of HSR and PRP. With Scalance's latest features, you can couple this HSR ring, bumpless technology. MRP rings offer benefits. A network disruption up to 200 milliseconds in one MRP ring won't affect others due to HSR technology. This helps network design. Use PRP or HSR upstream to prevent faults downstream. MRP works well downstream, supporting more devices with MRP functionality. What's more, with the latest innovations from Scalance, you can even couple multiple instances of redundancy mechanisms to your HSR. This means you can have up to 16 MRP rings, or maybe other redundancy mechanisms like spanning tree protocol, which we haven't talked about, to the same two devices in your HSR ring. What's great about this is normally if you wanted to implement more than one MRP ring, you would need to have two additional devices in your HSR to support it. With these innovations, you have much more versatility to implement these redundancy mechanisms into your network solution and achieve maximum availability. You now have some strategies that you can employ to minimize the effects or impacts of network disruptions and in some cases even prevent it.